Hey, it's Arvid, and this is the Bootstrapped Founder. My dear friend Jack Ellis is this unending source of founder inspiration for me because not only has he recently started embracing AI agentic coding, which is really cool, and it's something that he's been holding back on for quite a bit. I think I've mentioned several times on this podcast alone how he and I seem to have quite opposing views on embracing this technology, but something has clicked for him and he's been diving headlong into it. So I'm just excited. Over the next couple months, I hope he'll explore it more. And after that, I've been trying to get him to come on this podcast and talk about his experiences. So let's give him a chance and some time to explore it fully, and then we'll talk to him about that particular thing. But Jack said something else recently, which I found equally interesting and maybe even more generally applicable for all of us software developers building these digital businesses. It's just a quote from a tweet of his. He said, "The biggest mistake I ever made was storing our page views and custom events in different database tables. They're now on their way to a single table." And obviously, Jack refers to this wonderful product of his, Fathom Analytics, something that I highly recommend using for your own software products because Fathom Analytics is privacy forward and very easy to use. I've been a big fan of their work for a long while. And what he's talking about here is how the data model that they had in the past has been holding them back. And that's what we're going to be talking about today. A quick word from our sponsor, Paddle.com. I use Paddle as my merchant of record for all my software projects. They take care of all the taxes, currencies, they track the client transactions, and we capture them and update credit cards in the background so that I can focus on dealing with my competitors and my customers instead of banks and financial regulators. If you think you'd rather just build your product instead of doing all these other things, check out Paddle.com as your payment provider and merchant of record for your SaaS. Now, Jack is no stranger to massive migrations. And if he sees something that needs to be migrated to something better, well, I think he just goes for it at this point and writes a really cool blog post about it. And I find that admirable and instructive, particularly because I've been running into some of the same issues and it's really been helpful to see another perspective. I've been building Podscan for almost 2 years now. And obviously, the choices that I made on day one weren't necessarily the most forward-thinking ones. Because as we all know in this world of entrepreneurship, we're just all trying to figure it out as we go along, right? The meme that is often mentioned here is that we're all trying to build our airplane on the way down, plummeting towards the ground and trying to lift off before we hit the surface. Runway is another term from the aeronautics that is used for startups a lot. So I've been dealing with a lot of different choices that I made in the beginning, a couple smart ones and a couple really unreflected choices in terms of how the data in my database and my application is represented. And those choices have consequences, particularly for Podscan, where I have these millions of podcasts to track and all the extra data that comes with that. For each podcast, there's just so much metadata for the show alone, not even thinking about the episodes, just the show in itself. Things like chart rankings and reviews and social media profiles that are kind of linked to it maybe. And all this stuff needs to have a place. How you store it, what you store, and how accessible it is really makes an impact on how you can present the data to your customers and how you can use it to help them solve their problems. And then at this point, we're also over 45 million episodes in. So that's how much I've transcribed so far over the last 2 years at this point almost. That's 45 million transcripts. So not only do we have to store all that text data, but each episode has hosts and guests that need to be extracted and linked. And then there are summaries and topics for that particular show. There's just a lot of data. And some of that I structured smartly and some I didn't. And having a data model that is well designed from the start, well, now in retrospect, it feels like a really important thing. And it's a smart and important part of having a successful product. But here's the thing that I want to point out today, something that we don't usually talk about, because obviously scaling and all these things, they just happen and you figure things out over time. But how you structure your data, how you keep your data around informs how you think about your product as a builder. And if you only have certain ways of dealing with it, then features and ideas that would need different ways of using this data might be discarded and dismissed from the start. And this limits the whole scope of how you think about certain things that people who have similar products with similar data models might have as well, or may not yet have. It might limit you to certain things that a different data model or a different way of representing the data might facilitate, but you just couldn't even fathom it. Let me give you an example here. The most basic thing that we probably all can relate to, every software as a service business has this, is user authentication. People come to your website, they're interested, and then they go sign up. Now, what do you ask them? You ask them maybe for an email, a name, and a password, hopefully a password, some way of authenticating them. And then you persist that. So now in your database, you have a users table and you have a list of users. And that is how you think about your users. There's a list of things and everybody has a row in there. And all of a sudden, your business, right from the start, without doing much more than just persisting your user data, is a one user per account business. And this might be very useful for most people who use your product because they're individual people using it in their own ways. But then all of a sudden, somebody comes along and wants to invite somebody from their team in their business, right? They work in a marketing department or something and they have 3 to 4 people that they want to look at the data as well. Now, what are you going to do? Do you make the team member that wants to join create a new account as well? Because you don't really have a team representation yet. You only have accounts, right? You only have this users table. Maybe you have a permission structure that allows you to invite other accounts to individual projects or documents in your product, or you have an overarching organization structure that whenever a new account is created, this organization gets created as well, like a team. And then the team exists and the account is the owner and then can invite any number of members and make them administrators or editors or just users. There are many ways to deal with this. And depending on how you think about that, even that simple data representation that most software businesses initially have to make a choice about, how to put your users in your database, it depends on who you think your product is for. If it's just a B2C product where you have individual users, let's say you have a video game or a fantasy sports tracker where you just want to track your own results, it makes perfect sense not to even think about teams as a data representation. But the moment you plan on starting to sell to bigger companies, the moment you start selling to people who are part of a workflow, part of a team, if you don't think about teams and organizational structures here in your data model, your product will be aimed at people who might not be able to use it because they need to involve their coworkers. And maybe more importantly, they just expect things to have a team structure at this point. All the other tools they use have that. So that's one of the reasons why you really have to think about this in the beginning, and also why I really like the Laravel ecosystem. There are several really high quality plug-and-play systems for user authentication that come with the framework. And the one that I've been using in all my products is called Laravel Jetstream, which has a Teams option. You can immediately take Teams and make that part of your application by just using the --Teams flag when you install the plugin. And then every single new account either creates a team or can join a team. Like every account has a personal team and then can be part of somebody else's team as well. And that just comes right out of the box. It's quite useful to have this as a default for software as a service businesses, because at some point, some people will expect this kind of functionality for any significant product, and those people tend to be the ones with the money. So prepare for this. The moment you charge more than a couple $100 a month, it is quite likely that somebody will want to invite somebody from their team. That's kind of what I've experienced with the tools that I've been building in the past. Now, as you can tell, this conversation about authentication and users and teams has nothing to do with the actual internal data that your business handles. You could be rendering videos or generating emails or tracking where vehicles go or whatever in your SaaS. Doesn't matter what that data is structured like, just the authentication data. Just representing who is a user of your product that already impacts what your product can and cannot do. Think about billing too. Do you bill on an account level, on a user level, on the team level? Do you bill per project or per organization? Do you have seats? Do you even have projects? Or is all data in a team or in a user account? And how do they share it? All these choices truly matter. And once you make those functional choices in the beginning, then future infrastructure changes, or even customer representation that you have in your mind, if that changes, that has repercussions. Because if you change infrastructure like this, even just if it's mental infrastructure, you also change all the features that touch it. Existing features that may need some kind of connection to an account because they need to be bound to an account, but now all of a sudden you have teams that can be accessed by multiple accounts. Well, Can people just read all the data in there? Or is there like a permission system? What are you going to do? Assign an account, assign the team. The data model that you have in mind might not be the data model that you actually need. So you need to build some kind of flexibility for this as a founder from the start, right? You have to make strong assumptions to build any business, any software product, but you have to be willing to let them go more easily, because you learn along the way that things that you thought are cool might actually not work out well, because at scale, things can get quite problematic. If you think about Podscan as a database of all the podcasts in the world, which is over 4 million shows at this point, and all that they release, which is around 50,000 new podcast episodes a day, obviously those database tables grow massively every single day and have been growing massively from day one. Pretty linearly, because the world doesn't just double in size when it comes to podcast adoption, but they do quite significantly every single day. And what I experienced quite early on, a couple of 100,000 items in, was that my database, how I would structure my data and how I would make my data easily searchable and accessible, really mattered. I was trying to add indices to my MySQL database tables, because I was building new features on top of my existing data model that I thought was perfect, but obviously it wasn't fully complete just yet. Or I was trying to change fields in this database with millions of rows because there was something that just needed to be changed a tiny little bit. And all of a sudden, all of my queries to the database would stall for a couple minutes, because adding an index sometimes can lock up the database. And adding a new field or updating a field over millions of items certainly will lock a database. And that was when I didn't really know much about how to deal with this stuff at scale. Things like blue-green deployments, the idea of running a full new copy of the database as a follower on the primary database, then doing all the index and the changing work on that follower, and then switching it over. That's something that I've now been doing quite a lot whenever it's required, because that is the way this can be done without having downtime. I was not aware of this back when I started, just never had to use it. And I wasn't aware of how complicated it can be to add certain things to a massive database in MySQL. And it's something that now kind of needs an infrastructure event. I have to run this new deployment. I need to add a new index at some point, probably. And then I have to make an extra deployment, run the index on that kind of passive deployment, switch over. Otherwise, I would have downtime, which I cannot have because I have an API that needs to be reliable for my paying customers. And those are choices that I never really thought about in the beginning. I never thought about the fact that once my podcast episode table has over 10 million items, adding an index on a text field might take 2 days to complete. This stuff just doesn't come up when you're just starting out, and particularly when you don't have experience with that massive data collection. And at a certain point, data just doesn't have to do only with how data is represented, but also how it's accessed, particularly when it's a lot of data, like in my case. When you're pulling a lot of data from certain APIs or other kind of sources, the way and the speed at which it can be accessed really makes a difference. And even if you know a lot about databases and a lot about your customer access patterns, there will always be something that you will miss. So from the beginning, I would recommend thinking about how you can play with this data at production scale to see how things behave without actually running that particular change that you might want to make in production. Blue-green deployments have been really helpful. This approach is something that I felt is a godsend here, because otherwise I would have a lot of downtime, would have had a lot of downtime and the stress associated with that in the past. Let me maybe share another story from Podscan here. I mean, you're listening to this podcast. I talk about Podscan all the time, but this one is interesting because it is about full text search in all of my episodes. And full text search is something in regular SQL databases like MySQL or PostgreSQL, it's actually pretty good up until a certain point. And that certain point was reached within a couple days or weeks for me, because if the text that you're searching through is significantly large, then full text search starts becoming problematic. For me, with Podscan's transcription features, I have full episodes transcribed now for millions of shows, and like 50,000 a day. The full text search capability of MySQL, no matter how good that system is internally, just was not working with this. Not even with a couple million or even a couple 100,000. If I were to run a full text index on all of this now, today, on all this data, it would probably take me a couple of weeks just for the index to be built. It's wild. And second, queries on that index then, if it would even fit into RAM, which I don't think it would even on the strongest machines, would take several hours to complete. Each episode in the system sometimes has up to a megabyte of raw text data. You can't scan 50 gigabytes per day for months and years worth of data. That cannot be scanned quickly with traditional database approaches. So I was limited. I wanted full text search, but I couldn't do it on my database. I needed to split off that data into a secondary system built for this kind of thing. Initially, I was using Miley Search, and they were pretty good up until a certain point as well, because Miley Search is a very fast searching system. It's kind of used for instant search, type ahead search in e-commerce systems or specific database of very similar data, and it worked really well. But after a certain size, I think it was around 100 gigabytes worth of data, it became limited. Still very fast on the search side. They have this inverted index. It's really fast and it's all in memory. It's great, but much, much slower on the ingestion side. So I had to find an alternative solution, which ultimately became OpenSearch for me. And that's Amazon's version of the good old Elasticsearch. Now, at this point in my Podscan journey, I'm splitting off every single episode that I receive a transcript for or that I create a transcript for. I persist its full transcript in the database so it can be quickly accessed in full. And then I send it over as an item to my OpenSearch cluster, which takes care of all the ingestion and optimization and searching. That cluster has its own indexed version of all the data. And whenever we want full text search, we just send a request there and then populate the results that we get with data from our database. And then we show it to our customers. It was impossible to do this inside our own database system. And even if we had spun up a new MySQL cluster somewhere and tried to run full text search there, it would not be as performant. So we had to use an alternative system. Had I said I wanted everything to be done in my own database, I probably would have found a way to do it if that were like dispatch a search, get a result half an hour later, compile a report. But obviously that's not the feature goal. I still wanted it to be snappy. Product needs to be searchable, so I had to split it off, which means that now there's significant complexity in my data model. Right? I still have my MySQL database as my main database, my main source of truth, but I have these additional sources of, let's call it temporary truth, which are the search systems, for example. The text is still the same that I get from my API backend servers and then send it over to the OpenSearch, but the way we interface with the data and the way we have to synchronize it might be different. It's important to understand that now, for me, there's an additional control flow. If I were to retranscribe an episode because there was a mistake in it or they updated the audio or something, well, now I needed to make sure that the version stored in the OpenSearch cluster that people search on is also updated with this new data. And that synchronizing, checking, and testing, that is complexity that I didn't even think about at all from the beginning. But now I have to deal with it because of the requirement of having search. And even with MySQL's data, that's now several terabytes in size, there's more to think about. The database just grows and grows, but it costs me. That database can grow forever. I mean, it will be growing a little bit, but it can't grow massively forever. Most people only really look at the transcripts of more recent podcast episodes anyway. So that is a choice that I made in the beginning, keeping it all in the same database, all equally accessible. But was it a smart business choice? Probably not. It's probably fiscally irresponsible to store everything in a database you pay for when you don't even use most of it, or people don't even interface with the data more than maybe once a month or so. So I had to make a choice here too, after the fact. And I think this happened within the first 6 months or so of running Podscan. I started taking older data from my database and putting it into much, much cheaper object storage, but still making it available by linking it into the database. So what I'm doing now is a way for my podcast episodes to check, is the transcript fully available in the database? And if not, do we see a link to a storage file in there that might contain this transcript? If so, let's load it, write it into like a cache for a hot minute so we can serve it quickly without having to pull it over and over from our object storage for like a couple minutes. And I also make sure that once the podcast episodes in my database reach a certain age, they automatically get shoveled over, transferred into object storage, kind of a colder storage if you think about it, instead of staying in my hot and always accessible database. And this, once implemented, works super reliably because like S3 and AWS RDS, where the database lives, they're all very reliable systems. It saves me a lot of money on these millions of podcast episode transcripts that are now just sitting in JSON files somewhere. Not only do I save the transcript, I also have like per word second level timestamps for every single thing I transcribe. So not only is there like a megabyte of transcription with human readable text, but there's a big old JSON object that has timestamps for every single word that is uttered in that thing, which is often up to 8 or 9 megabytes in size, just because of the verbosity of JSON. I compress that and automatically write it into cold storage as well and make it available if people ever want to download it. So you have to think about all these kind of things all the time. And none of this was part of the initial data model. I didn't think I would ever have to think about that kind of optimization or shoveling data around, but that's what I wanted to bring up today. The way you represent your data either enables you or it limits you, and probably does both at the same time. And if you find yourself struggling, think about how you can bend not just your application to fit the data model, but how you can open up and make more flexible your data model to fit what your application actually needs to become. Don't limit your thinking to what you chose as a data representation at some point. In fact, change the representation, add to it, make it maybe a little bit more complex, but don't let it limit what the thing you're building can be. Know that it can be done. It just requires patience, sometimes infrastructure events like a blue-green deployment. Sometimes you have to bite the bullet and do a little bit of downtime or have a big anxiety-inducing migration. But having a data model that is flexible enough to be changed even at scale and under load becomes very relevant as a tech stack decision. It's not just about what framework you use, what database you use, but also how your data stays flexible when changes come along. Because change always comes in a SaaS business. You're never going to be done with it. Customers always have something that they need. You always have that new feature that totally needs you to be able to store that one more thing in relation to your data. Just build that internal flexibility as a founder to say, okay, this month I'm going to do that migration. It will be worth it. And that's it for today. Thank you so much for listening to the Bootstrapped Founder. If you're a founder, a PR expert on a marketing team, you might be missing critical conversations about your brand right now. And I think Podscan will help you with this. It monitors over 4 million podcasts in real time, and it alerts you when anybody, influencers, customers, competitors, mentions you. It takes this unstructured podcast chatter and it puts it into interestingly hosted competitive intelligence and PR opportunities, customer insights, all with a really cool API that is very responsive and flexible because I built it. And if you're a founder searching for your next venture, check out ideas.podscan.fm, where we take startup opportunities directly from hundreds of hours of expert discussions every day, so you can build what people are already asking for. If you know anybody who could use this, please share it with them. You can find me on Twitter at Arvidkahl, ARVIDKAHL. Thank you so much for listening. Have a wonderful day, and bye-bye.